Sound testing. 38 seconds. Hello. Sound testing. 38 seconds. Sound testing. 38 seconds.
Hey, Don.
Hello.
Hey, everyone.
Mr. Edwin.
Hello, hello, hello. All right, all right, all right.
Come on, turn on the camera, guys. I'm gonna be the only one.
No pressure, no pressure. I'll turn mine on so we're not pressuring people to turn it on.
Thank you. Hey,
Am I
man.
gonna become famous if I put it on? That's our dream for you, Edwin. We're gonna make you famous. Your face, the face of leak code programming. I do want to be famous. Yeah, I mean, let me see. Let me see what my hair looks like. Nice. Oh, you got a hefty stack of books in there.
Hey, Edwin.
All right. Yeah, I mean, this is not like a very clean background, so.
It's okay.
Where is Evan? How's everyone's week? How is COVID doing? What are you guys up to?
I just came back from a run.
Alrighty. Not a lot to talk about in terms of like the administration end. We are still trying to do a push for getting more people onto here. We'll kind of see how that plays out. June is kind of our big month to kind of push for some things. I think the kind of discussion-led conversations are doing a lot better than most things. So I think that's a great way to like kind of introduce people or convince people to kind of show up so that they can kind of talk about code.
We've lost Matt.
Still kind of occurring remote. It's a way to kind of hop online and kind of talk through either coding best practices, what's going on in the industry, kind of share some news about what we've been working on, things like that. So that's kind of the big pitch that we're doing, and there's a few channels that I have yet to blast, but that I'm probably going to do over the next week or so, and hopefully next week we can get a good showing. For next week's topic, we'll probably do something that's a little bit more accessible to people across the spectrum. So we'll probably do something about like coding milestones, or like what is like the software engineering journey, like what should beginners be doing, what should intermediate engineers be doing, and what is like a senior engineer, and what kind of defines that realm. And I think that's something that kind of all people can kind of contribute to, and also all people can kind of ask questions on, and kind of get feedback and ask if they're, and see what other people think about their perspectives on that topic. Yeah, so that's kind of the majority of it. As it's getting hotter and more people are spending more and more time outside, I think important to kind of keep revisiting what this community is about. So if anyone has any thoughts on that, please reach out, and as always, you know, to you guys on that as well. Okay. So without further ado, Edwin, do you want to take over leak coding?
Sure. So let me share my screen. Going live. All right. So this is another classic graph problem, and I think last week that problem, essentially, the n queens problem is a harder version of this kind of pattern of doing a graph traversal. So I think it's fruitful to return to the basics and just essentially examine how to traverse a graph and to clone it. So that would be our task for today. And this problem is because of the leak code. It takes a while to get familiar with the leak code way of doing things, but I think that's also a very useful exercise to really understand how to shape your inputs that leak code gives you, and how to understand and interpret them, and then also how to return the result that leak code is asking for. So this problem is very weird in that aspect, that the inputs and the outputs are not very intuitive to understand, and it's really just reshaping the result so that it would pass the online judge. But I think it's a useful exercise to do, because if you ever do HackerRank or leak code for interviews, you have to understand the inputs that they're giving you and also give them what they expect, so that you can pass the test in the online judge. So the question is, given the reference of a node in a connected undirected graph, we have to return a clone of the graph. So you can see in Python 3 that they give us, they already made a type of a node for us. And if you're familiar with graphs, this shouldn't be too dissimilar. We're given a value for each of the nodes, and then each node also has neighbors. So now we need to understand exactly what the input that they're giving us is. So they're saying that each node's value is the same as the node's index, and they're starting at index 1 instead of index 0. So the first node has value 1, the second node has value 2, and the graph is represented in the test case as an adjacency list. So in this adjacency list, you can see that there's 2, 4, 1, 3, 2, 4, and 1, 3, and each of these are the neighbors for that particular node at that index position. So we can see that in this adjacency list that there's 4 nodes in the graph, and the first node at index position 0 is pointing to 2 and 4, and you can see at this graph it's 2 and 4. The second node is 1 and 3, and you can see that at node 2 that it's pointing to, well, it's an undirected graph, so it's connected to nodes 1 and 3, and then the third node is here, and it's connected to 2 and 4, and the fourth node is here, and it's connected to 1 and 3. So very simple graph, and our task is to return a copy, a deep copy. So we can't just return the graph itself. We have to return a separate graph, but that looks like this. So you can see that this looks like a clone. All the nodes have the same values and are directed to the same nodes. So that is a legal clone, but you can see it here. This graph is not a legal clone because the nodes are messed up. So we can't return the same graph, and we have to preserve the relationships between the nodes, and also, of course, the nodes' values 1, 2, 3, and 4. So here's another example. Example 2 is that we have a list within a list. So that just means that we have one node and it's not connected to anything else. It's just by itself. And you can see that in a test case of just the empty list itself, this is just an empty graph. It doesn't have any nodes. And then you can see in this adjacency list, we have 2 and 1. So remember, the node at position 0 has a value of 1, and its neighbor is 2. So that's a lot to keep in track, but that's this is how they're representing the input as an adjacency list. And you can see that there's a second node at index position 1 that has a value of 2 and is connected to the node of value 1. So if there's any questions in terms of the inputs and the examples they've given us in our task, let me know now, and I'll go ahead to actually solve this problem. So in terms of a graph problem, when you really see this graph problem, I think it's very, we're going to do, I went through DFS multiple times in the past few weeks, and we're going to do another recursive DFS because I think it's always worth repeating it. But our task is really, like, always think of traversing. Whenever you see a problem like this, we have to traverse the original graph, and then we have to clone it, right? So that's our task. We can't just do a nice traversal of the graph. We actually have to be doing something while we're traversing. So what we need to do is we need to have a mapping between the original nodes and the copy and their copies. So since we're doing recursive depth first search, we always must have a base case. So let me say if there is no node, we just do a simple return. And now we do the copy here, right? So in terms of making the copy, because we're already given the definition of a node, what we can do is I can call this just a copy, and then I could make a node, and then given the input of the node, because, and this is where LeetCode gets, it was confusing for me at first too, so, but what they're giving us is just the first node. So they're just giving us a reference of the first node, and then this first node has a value of 1, but it's able to keep track of everything else because of its neighbors, because it has an attribute, neighbors, and each of the neighbors has their own relationships. And as a result, what we can do is we can actually return the copy of the node of just a single node, but we just have to make sure that their neighbors are in order, and that would actually be our answer. So we don't have to return essentially the whole adjacency list, because in their test debugger, they're just going to look at the neighbors, and they're able to find out if the order is preserved. So it's a little bit confusing, especially also writing in Python, but what we need to do is we're given a reference to a node, and that node has neighbors that are references to the other nodes. So we're not returning, so we don't need to return the whole graph because it already has pointers or references to their neighbors. So now we need to, so we have to do a traversal of some sort, and we have to have a mapping between the original nodes and their graphs. So let me make the mapping right now. I'm just going to call this a map. That's a key word, so I'm going to call it a dict map, a dictionary map, because dictionaries are a very useful way of representing graphs in general, and very efficient way as well. So we're going to call this, so we're going to have the node that is given to us as the key, and then we're going to have a copy as the value. So now we have the mapping between the original nodes and their copies, and now we're going to do the depth first search on it. So what I can do is I can make a depth first search here or as a function. I think I'm just going to make the function separate. But what we're going to do is we're going to do a depth first search, and then we're going to traverse through the node that we're given, and then we also have to pass along the dict map of all of its, so that we can keep adding to the mappings between the nodes and their copies. So now we just need to write the depth first search, and then we're given the node, and we're given the dict map, and then in a depth first search, what we need to do is we loop through each of the neighbors in the node's neighbors. And while we're looping through the node's neighbors, we're also doing the depth first search for each of the neighbors. So you can imagine in terms of recursion, as a review, we're going very deep for one node and its neighbors, and then once we hit the stopping point, then we check the other node's neighbors, and we go deep, correspondingly for each of the neighbors in turn. So and then we pass along the dict map. For this problem though, we care about whether we want to keep adding nodes to the dict map as we pass along the dict map to each of the recursive combinations. So we have to exactly check to see if the neighbor is actually inside this dict map already. And if it's not in the dict map, we keep recursing over. However, if it is, then what we can do is we can just say that the dict map of this particular node as the input, we're going to append the neighbors, and we're going to append the dict map of the neighbor. So this means that the dict map, as you know, like we've defined it as the value we're given is the copy of the node, and now to this copied cloned node to its neighbors, and we're appending the dictionary map neighbor copy. So we're building our own separate cloned copied of the graph. And now, so that reminds me that, so that takes care of if the node already exists in the dict map, but in order for it to already exist in the dict map, we actually have to, if the neighbor is still not in our dict map, like in the first few nodes most likely, that we haven't even defined the neighbors yet, so we have to build them up. So in order to build them up, what we need to do is very similar to what we did above here. We could do a copy here, and then we do node, and then we pass along the neighbor's values, value, and then we have a copy, and then in this copy, we pass along, we make the copy node, the neighbor equals copy, and of course, and it's not merely enough that we found that we're trying to build a neighbor in our dictionary map and making a new additional clone node in our dictionary map. We also have to make sure that its neighbors are in order. So we can do, actually, I think what we need to do is we need to add to the neighbor, the node that we're given, that we found a neighbor because it's not in dictionary map, so we're going to create it, and we're going to copy it over. But I think we need to pass along the copy because I think we can actually pass along the dict map neighbor. Or we could pass along the copy. But either way, we're going to append the neighbor, and let's see if this works. So neighbor is not defined, and neighbor. Let's do that. All right, so it's accepted, and let's submit it. And yeah, it works. So in closing, what we're doing is we're traversing the original graph, and during our traversal, we're using a recursive depth-first search, and inside this depth-first search, we're going to create mappings between the original nodes and their replicas, their copies. And in a depth-first search, where we go through every single node, and for every single node's neighbors, if we haven't already put it in our mapping, we're going to make a copy, and then we're going to construct, we're going to make sure that the neighbors has the right, we're going to make sure that in our mapping that those neighbors have the right copies, and then we're going to continue doing the depth first search for each of the nodes in turn until we hit the base case and we don't have any nodes, and then we just return the copies. Any other questions besides that?
Edwin, I just have a question. So the use of such knowledge, this is just to get to be good within interviews, or this is related to to like a specific focus in coding or machine learning or whatever it may be?
Yeah, that's a good question. What I would say is for all of the above, because like these questions are very common in interviews, but recognizing the utility of a graph data structure is very important in software engineering, because you would see that many problems devolve to a graph problem, and knowing how to traverse the graph well is something that is really necessary for in order to make really elegant solutions. Because otherwise, if you didn't know that a graph existed and you don't know how to traverse it, you may be ending up with very hackish solutions. So, like, just to give an example, there's many in terms of whether to check for valid states, whether certain entities, let's say you have a lot of state machines, and you want to check that each of these, like, whether a state machine is in a valid state, it really lends itself well to a graph data structure, and then you can traverse to check if whether that state is valid or not. And because especially if these state machines have relationships to each other, so it does find itself like oftentimes used in industry. So it's not merely like an interview problem or an academic exercise. Does that make sense?
Yeah, I get you. I just maybe because I'm like barely fresh at this stuff, I don't know what a state machine is. So maybe if you can like guide me some more, maybe this when you guys and when you send in the emails out, just if there are like some articles, maybe I need to just to get myself up to speed with the overall understanding of what is a state machine and the use of the traversing of a graph.
Yeah, I mean, to simplify it, so let's say that we have a graph. So let's say we're building a social network, right? And each node is a person, right? And each person has values associated with them. Let's just say it's a very simple value. Let's just say it's an ID, right? So in this, let's see, if you look at this original graph example, let's say we have a group of 4, and I'm number 1, right? And I'm friends with number 2, let's say that's Tom, and number 4, let's say that's Matt, right? Okay. But let's say that you're number 3, and I'm not connected to you, right? Okay. But let's ask the question, am I a friend of a friend, right? Are you a friend of Tom or Matt? And let's say you are, right? So then the graph will look like this, would it not? Right?
Yes.
And then when I'm presenting to you friend recommendations, let's say a very simple algorithm is just friends of friends, right? No crazy AI. We're just going to show, like let's say when I log onto my own social network and I want to make more friends, they're just going to show me friends of my 2 friends, Matt and Tom, right?
Oh, Mark, secret.
Yeah, so you can see how we have to traverse this graph, right? Using a variety, like either using depth first search or breadth first search. And then we're able to see that, and then the social network algorithm can return me you, right? And then it'll recommend me you because you're a friend of a friend, right? Does that make sense?
Yes.
Yeah.
So perfect sense, actually. Yes.
Yeah.
Perfect sense. Yeah.
So that's why traversing a graph is very important. So this kind of problem, like cloning a graph, right? Let's say that this social network database has like this data, right? So it has me value 1. It's giving me this adjacency list, right? I'm connected to numbers 2 and 4 to Matt and Tom, and number 2 is Tom, and he's connected to me and you, and then number 3 is you, and you're connected to Tom and Matt, 2 and 4, and then Matt is connected to me and you, right? So let's say that I want to copy this. I want to clone this graphical database. Then you would have to do something like this, right?
Yes.
Yeah. So it is like, it's not just merely an academic problem, but but it's learning how to traverse and also have like cloning a graph, having a mapping between original nodes and their copies. I think finds itself in industry, but obviously, like it's not something that you can always like memorize, because you can always look this stuff up in industry, and there's no time pressure. But I think recognizing that this is a graph problem and knowing the basic fundamentals of graph traversal is very important. Does that make sense?
Yeah, yeah, perfect sense. I appreciate the example made and the cluster clear, honestly. Yeah, appreciate it. Thank you so much.
Yeah. Any other questions? All right, that's it for me. And I'm always available for other questions.
Very cool. Thank you, Edwin.
Appreciate it.
Thank you, Edwin.
And I did want to touch on graphs. I was once told the point that graphs are good for many relationships, and that is kind of, I think, the most poignant way of kind of describing them. Anything that is many people, you're trying to talk about the connectedness of many objects to many objects, graphs are going to come into play, and that's 100% true. So did want to touch on that. We're supposed to have a discussion right now. I want to present on something because I did work on something cool over the weekend. So did want to show you guys something relevant to something that I've talked about in the past. Share your screen.
Edwin.
Okay. So I want to talk about decorators again, because that's something that I've worked on a lot recently, and I think that they're a great way of cleaning up your code base. This function is going to be very complicated, but when you kind of break it down, it shouldn't be overly complicated. But essentially what this does is it creates, if you go to my test file, it creates this logger object. And this logger object essentially attaches itself onto a function, and then it's going to print out when the function starts, and then it's going to print out when the function ends, and it's going to print out the output of the function, right? So we can kind of see that we create the object, we call it, and we see that the response is success, and then we use the testing framework we've had to essentially make sure that our mock function has been called twice, and the first time it was called with basically the class that we're talking about and the function that we're talking about, and then the same thing with the output we're talking about. So let's show what this looks like as terminal output. And so these are all the functions that are being called inside my program. But the only thing I had to do to add that function to a program was to add that decorator onto a function. And so rather than having to print at the beginning and at the end of every function, what I was able to do was simply abstract that out into a decorator and do that. And I really think that decorators have a huge potential to kind of clean up a lot of code bases, especially if you find yourself doing repeatable things, not just at one point, because if you're doing something repeatable, you can kind of abstract it out to a function. But if you're doing repeatable things on entry and on exit to the functions, right? So these are things like caching. Caching decorators are great. And in this case, logging, because I'm logging on entry into a function and I'm logging on exit to a function. And so this is just something that I've been working on that I thought was cool. If anyone is interested in this more, please reach out, because I do think that these decorators are cool patterns. And we'll kind of come back to them periodically and talk about them again. But for now, I want to kind of. Was there a question?
Do we have a minute just to go over this again? Just 1 second. So for the
Sure.
junior people here, so what that exactly does, like what that makes the code better, like in terms of, I don't know, it makes more efficient, it's faster, or you have to code less.
So let's talk about what I was doing before I was using decorators.
Mhm.
Actually, I'll even change my code, right? So let me go back a previous branch. There's a little bit of an abstraction here too already, but we'll talk about it later. Am I showing my VS Code right now?
Yeah.
Awesome. Of course, start log task. This is something that I did very frequently. So what I created before I did it in decorators is I did something called a log task.
Mhm.
And even if I just go to the definition here, what this does is it simply takes the string that's passed in
Right.
and prints it, and then it returns a function that's meant to be printed when it's done. Right, so this is me saying that the task is started, in progress, and this is me saying the task is done. And so when I kind of go back to this, I start the log task, which means on line 144, I print out load repo, and I also print out in progress. And then I get back a finish function. I only call the finish function after I've done the thing that I'm trying to finish, right? So here I have, essentially, I'm taking 2 steps to both print that a function has started and to print that a function is ended. So let me even run my code base and show that it works. I'll hop over to right. So there was like a little bit where it was running. It's actually a little bit wrong, but essentially what ends up happening is each of these things first gets printed as in progress, and then it gets overwritten as done. And so I'll run that again. It's a little bit quick because the program is not that slow, but essentially what you can see. All right, so the app is starting, and then it starts hitting all the code. And so here's an example. Like each of these things both at first printed something saying to start it, and then afterwards printed something to finish that statement. And so instead of literally writing, like what I could have done is, so this is JavaScript, so I could have literally done, exit this out, I could do console.log load repo, and then I can console.log load repo finished, right? And so we just kind of drop logging statements when we're coding just to kind of see what's going on. We'll often, I'm just not sharing the right thing. Change windows. So I've changed this line here to just be a console log, and I've changed this log here to be a console log finish, right?
Mhm.
So essentially, I'm just trying to figure out what's happening in my code base while I'm listening, while I'm watching the logs, right? Essentially, my program's executing, and I'm being like, okay, I want to know where things break, and I want to know what the last thing executed, so that if something goes wrong, I can actually trace back through those steps. And so that's kind of the actual thing that I'm trying to do. But how I do it is the different levels, right? So here's the simple console.log, right? All I'm doing is adding print statements to my code everywhere. I'm adding print statements both before functions and after functions. What I can do instead is I can go to this repo function, and instead, if I check out my code base in its current form, add a snapshot. I'm doing the exact same thing that I was doing before, but I'm just doing it as a decorator. And so it might seem trivial doing it in one line versus two. And in some ways, it's very arguably is like a trivial thing to just save on one line of code. But where I think these things kind of really shine is trying to so for example, in this return statement, if I wanted to start printing this, I would actually have to declare a few more lines. Like I'd have to declare a result of this function. I'd have to assign it to a variable, right? Then I'd have to console.log start. Right at the top, I'd console.log a finished, and then I'd return the result, right? And so this is actually a pattern you might see yourself doing a lot. Right? You do a complicated thing, you assign it to a result. You don't actually return the result immediately because you want to do something both. You want to do something right after, but you ultimately still want to return the result, right? And so instead of these 4 lines of code being like this,
right?
If I add that decorator, I have that. And it does get a little bit complicated, and these are definitely like advanced tools to be using, but I personally feel like the less code you're writing, the less likely things are to go wrong. And so,
good point.
Decorators are sort of very able to clean these up, and I think decorators are a good example. I mean, even functions in and of themselves are good things. So if you, in the last instance,
so I'm sorry to interrupt, but so basically you are like coding with less lines of code.
Yeah. So not only less lines of code, my abstraction, right? So what I want to do is I want to print something before and after a function executes. I don't have to do within every function. I've defined all of that logic within the decorator, right? And then I just add that decorator on everything else, right? So instead of having to be like, oh, okay, every time instead of having a mental like paradigm and being like, okay, I want to print before and after I execute every function so that I see it, I code that into a decorator, and it's a coded paradigm. It's no longer just a logical thing. It's no longer a rule that I just follow in my code base. It's literally code that exists in my code base that is the rule. And so that distinction is like a little bit subtle because at the end of the day, it doesn't really impact performance. It doesn't really impact the business logic ultimately should be the same. But the reason it kind of can help clean up code bases is because a lot of times you'll see the same patterns over and over again. And so kind of the first step to do that is to follow the pattern better and make the pattern very simpler, and to do that console.log before and that console.log after, right? That is a good level of abstraction if you're kind of like, I'm going to create a paradigm and I'm just going to follow it. But there are next steps after that to be like, okay, I can mentally come up with this paradigm. Now I can kind of change my code base so that the code does the paradigm and the user no longer does this. And that paradigm of logging before and after is literally kept within these 2, 4, 6, 8, 12 characters. Right? These 12 characters summarize that entire paradigm.
And obviously you can do that in Python, right?
This is JavaScript.
No, I know, but you could do. Oh yeah, because all right.
In Python, decorators are actually even simpler.
Nice.
JavaScript, they're a little bit more complicated.
Yeah. You had you touched on you gave some lecture in like a few I think a couple of months ago, like something.
Yeah. I
Yeah.
think it was even actually when we were recording it. So there might still be a lecture on me doing decorators, and this is kind of like one of the big things that I've been focusing on in terms of just trying to figure out how to be a better coder. And I think this is one of the good things that are coming out. Decorators and basically GraphQL are like my latest obsessions in the coding world, and I think they're very good paradigms and very good ways of kind of forcing you to write code in a specific way that is good code.
Yeah, I have more questions for you, but later on about Git. If you could do Git with the decorators as well, like you can like do that block of code of like I don't know, say Git add and like
Different. So those Git programs are in Bash, right? So they're written in terminal.
mm-hmm.
What you could do is you can create a function in terminal. I generally don't, even with those, right? Because you're thinking, right, like you do git add period, then you do git commit dash m, and then your message, and then git push, right? And so why is that 3 separate commands instead of 1 command? And you could write a function that does all 3 of those things at once, and you could even do that as a function that takes in a message, so your message could be dynamic. And at that point, you're writing that function in Bash. But I would
No, just as an example
Git,
as what you could do.
yeah. So you are right in the fact that you're abstracting things away, but that abstraction is simply done by a function,
Wow, okay.
right? You can group the same code by simply a function. Decorators are specifically if you want a function to execute both before and after something else, or if you want it to exist on in a different level.
Oh, I see. Yeah, that's more complex. Okay.
Yeah, and so they can be tricky, and I don't think people should jump right into them, but I do think they should be on kind of people's horizon.
Alrighty.
Okay. If there's no other questions, we can kind of hop into.
Yeah, Matt. I just have a question. So especially with this like memoized like or like cached like decorators, they can be painful to debug. So do you have any tips on that? Because it's essentially caches are very like I found in based on prior experience that they're very hard to like if there are problems, right? And then it's like, oh wait, it's just a cache. So
Yeah.
so it's like, is there like best practices in terms of like flushing the cache or adding stuff to the decorators or something like that to like obviously it looks very clean from like to use like these cache or LRU decorators or memoized decorators or whatever you want to call them. But I was just curious in terms of like the best practices in terms because they do are often a source of problems I've found as well.
Yeah, I mean, so caching is a double-edged sword. I don't think that's a problem with actually using decorators. I think that's a problem with using the cache. So when you do the LRU decorator, what you essentially want to make sure is that you have a pure function. And by pure function, I mean something that, given a set of inputs, the outputs is always the same, right? So there's something that the coders talk about in state on the outside, and this is a good example of that. Because what we essentially want is we want the variables we're passing in not to be stateful, so that when we pass in the same variables again, we are expecting the same results, right? And at that point, a cache is perfect, right? Because we've already computed the function once, and let's say it's an expensive function, and it should always be returning the same things, so we'll never have that problem. The problem is when we're not expecting that to return, to happen at the same time. Let's say we want a cache that's busted every hour, right? So at that point, we have not just a memoized paradigm, we don't have pure functions, and we don't want to just save it if we computed it. We want a more complicated thing, where essentially we check the cache, see if it exists, and then we also see when it was put in, right? And so the LRU cache decorator, which is in functools in Python, is a lot simpler. All it does is check, have we computed this function before? Oh, we've computed it before, let's return the value we've computed. so that is like if you want to add cache busting to your decorator, then you actually have to implement your own decorator. And so in Python, I don't think it's actually that tricky. Essentially, you implement a function that takes in another function as a parameter. I think that's the one I did the lecture on is decorators in Python. But yeah, so you don't want to be using the LRU cache at that point. Does that make sense, Edwin?
Yeah, it's just yeah, especially if you have to add those checks in for the cache. Like I agree, as long as it's idempotent, then the cache makes a ton of sense. And it's always best practice to use a cache, so you don't have to recompute things. But it's not like looking at the table to see if like the value is there. It's like it's kind of it's more of a code. Like you have to make checks in the code. So it's just hard to debug. Just checking to see if like a table has like the right values that you expect, or doesn't have the right values you expect.
Yeah. I mean that's like a big source of problem, and where to cache and whatnot is like a huge concern. And I think oftentimes those are like many times I've gone through a code base where you start adding caches, and then a couple months later you're like, oh, we have to take all these caches away because we're no longer able to reliably use these caches that we're using. And so you have to rethink kind of your paradigm. But all this memorize function does is it kind of is like, so here right now I have a function that takes no input. So essentially all this does is it checks if I have, let's say I had a cache object, right? If this had a cache object, and the cache object had, nope, it's gonna give me errors because I don't have a cache object on it. Dot file map, right? Right. So if there's an object there, then I return this dot cache dot file map. Otherwise, I actually do the computation, and then when I do the computation, I assign it to this dot cache dot file map, and then I again return the same thing. Right. So here's another example of what I'm saying. Things being done before and after, right? So before I do the actual immediate computation, I check the cache, and after I return what's in the cache, right? And so here I'm essentially doing something before and after, and that's why I'm able to kind of do this instead of doing it as this paradigm, where I have a cache and then I check the cache and then I update the cache and whatnot, then I return it. What you're essentially talking about is I first check the cache. And then what I essentially want is I want the cache to also have some sort of update value, right? So I want the cache.file map file map time is less than date now plus however we do like 1 hour, right? So it's probably like 60 times 1,000, right? So that's how we would check if the cache is expired in an hour. And then we don't assign it to the file map, we assign it to the value. And then we also assign this dot cache file map dot time is equal to date dot now. And then we return the value, right? So this is a similar paradigm, but with a cache busting after an hour built into it. And so if you're having issues with the functools LRU cache, because it's not busting at a certain point, you're going to implement a decorator that does something similar, where part of it was the thing that LRU cache is doing, but then on top it also does this kind of time checking to figure out when things should be to see if the cache value is still considered valid.
Yeah, and then it's like it's a decorator. It's another decorator. It's a super decorator above the LRU cache decorator. Or
so
just
I would implement one and then forget about the LRU cache. You can do a thing where you do multiple decorators in a row. I've actually done that in this project. I tested for it somewhere.
Yeah, Because I'd rather do that because I don't want to re-implement LRU cache. But yeah, totally understand.
So in this function, I have a catch exception decorator and a memoize decorator together. And so here specifically, I want the catch exception decorator to occur before the memoize, because I don't want, because the way memoize works, well, actually I think the way I resolved this was that it didn't matter, but there are times where you care about the order of decorators, and that's when things become super complicated and very hard to think about. But essentially what ends up happening is you think about it once, you figure out the pattern, and you're like, okay, I do it the memoize first, and then I do the catch exception, and then you make that a rule, and that's it. And so then from now on, this is what you're going to see my functions kind of looking like. But yeah.
Yep, makes sense.
Cool. All right, let's go to the Google Doc.
I just wanted to ask a general question.
Sure.
So I'm using the Mongo DB because I'm scraping a bunch of data. They of course might not be of a similar like length or columns, so that's why I'm using the Mongo DB. But is there any way I can just like not go through the step of connecting to the DB and doing all of that and just creating a dictionary in Python itself?
What are you using the database for?
So I'm collecting, for example, like I'm doing a bit. I was building a scraper for Etsy, and for example, the number of pictures inside each item is different with the description, and some items they have different sizes, and some just have like a singular size and a price.
Okay.
So I was collecting all of this information, scraping it, and I was building a table so that I can use this table and upload it to some other website. So I had to go through the process of storing all of this in the Mongo, depending on the item like length of different parameters, and then just extracting an Excel sheet out of that. And I was wondering if I can just overcome this step and have that stored directly in a dictionary. The issue with storing in a dictionary is updating the right value, because a single key or something is not enough, and even multiple keys is going to be really hard to create. Just to know which value that I'm updating or just adding it to a different data frame.
I mean, honestly, so if you think about a database like MongoDB, that's like a NoSQL database, it is essentially a dictionary. It's a giant dictionary that can scale up and have hundreds of thousands of records and whatnot. But at the end of the day, it's a key value store, right? Well, it's a series of key value stores and collections. But if we're talking about a singular collection, you have an array of records, and then in that array, you update on things.
Yes.
There's a few caveats. It's updated. It's performant for things like reads and writes, right? So if you wanted to, if you had an array of values and you want to update the value with a certain ID to have some other value, that's going to be a lot more performant in a database simply because databases have things called indexes where they reference the objects directly. So it may be more performant to use a Mongo instance, but even then, I don't think that to be the case. So given the problem you've been talking about, what I would do is I would find something that makes all of my records unique, and let's call that the ID, right? And so let's say it's the URL, right? So we're scraping Etsy, we have a bunch of different URLs, and every URL corresponds to a thing that is being sold on the site that we're trying to log and create an Excel spreadsheet for. What I would do then is I would use that URL as the key to a dictionary that we're describing as the object. Our big dict, which is essentially our database, the key is going to be the URL, and that's going to map to all of the objects corresponding to that URL. Right, and then at that point, the read and write is super performant because you're doing it just based off of indexing on you're just pulling the value from a dictionary.
But my issue was the different sizes between items. Like in a dictionary, it's so the Mongo is a list of dictionaries, right? But it doesn't care. It doesn't care if one dictionary is made up of 5 keys and the other is 6. It doesn't matter. It just dumps them. Right? You can throw in whatever you want. The regular dictionary is if one of them is one item is a length of 5 keys. The second must maintain the same length. Other than that, it's just gonna crash. Like it's going to.
Are you talking about a Python dictionary? Or are you talking about
yes.
like SQL Server?
Yes.
Python. So yeah. I'll even check it out right now.
Sorry if I'm derailing the conversation. I just had a thought. I don't know if
No,
if that's fine or if you want to do it like.
We'll take a second, and I think we can address this real quick. I think a few people might actually like this. If anyone has thoughts, please feel free to speak up.
Andre?
I don't care. Shut up.
So yeah, chiming in here. So you're scraping Etsy, and you have, I guess, URLs and some other data that they point to. I don't think I'm quite understanding the problem. Why can't you just dump it into a dictionary in Python?
Because it's going to be of a different length. Like one item could have let's say pictures, for example, description, a single price, and a single size, right? Other items might have 10 different prices that you need to capture as well, and these 10 sizes would also have their own prices and so on and so forth, and even the description or the element that describes each price or whatever that may be, even the title itself. So in the process that I'm having and the complaint itself is sometimes Mongo is not like stable. Sometimes it just like some items disappear for no obvious reason, even though if I like set a flag in the code itself, okay, like at this point the item is created, and at this point the item has been scraped or whatever the flag is. So so I wanted to, instead of having to go through the Mongo step, just install it. Store that directly in a regular Python dictionary. So, but when a Python dictionary has a key of 3, which is like the title of the item, the single price, the single description, it will crash if I give it in the next run 4 different prices of a 4 different length of a 4 different like images, right? There could be something different. So this is my issue. That's why I have to like dump it first in the MongoDB. And I just wanted to do some sort of a workaround because the Mongo hasn't been that reliable in the past, like my past couple of experiences with it.
Okay, I don't quite follow. So like, okay, whenever you're inserting or setting a key in the dictionary, are your keys what? What are your keys? Are they all different? Are they all hashable? Is that Is that the problem you're encountering, or what exactly is your key here?
Yeah, the key itself could be the title of the item, the code, or it's definitely unique. It's not. I think so. From my experiences, the issue wasn't the key itself, it was just that the different length of items that I'm inserting in the dictionary. If it's not
Okay,
consistent, yeah.
So what happens, like, let's say you have you're inserting something into it. You're doing I don't know, dictionary.set, or you're just setting it directly by indexing on the particular key. What happens when you do dict key one equals blog, data blog, whatever that is? Well, what does it do?
It would show the first item is just that it might insert and overwrite some existing item, or it might not just accept it altogether. And
What does not accept mean? Like, what is the
like it would just throw an error. Like it will throw an error that the keys have not been defined.
Mustafa, do you mind? Can you see my screen?
Yes, I can.
Right. So this first block is defining. Essentially, this is an array of values, which is one way of defining everything, right? Where each entry is essentially going to be a one entry that corresponds to an item on your site, right? So here we have two dictionaries in my array that each have a name. Each of them have a name, but one of them has a last name and the other does not.
Okay.
So that works both for my dict as well, right? So if I define my dict, I can have a key, which in my case, it's going to be my name, Matt, and your name, Mustafa Awad. Sorry. This dictionary works as well. And so essentially what should be replaced is this key should be your title or whatever makes an item unique. I think URL is actually the best one that I can come up with. And then each of those values can be whatever you want. The problem might be, so if I do something, like if I iterate through all of my, for KB in my dict, is it iter rows? Does anyone know? All right. Print K.
You could just do dot items.
Oh, items. That's what it is.
Too much.
Iter rows is old.
You're doing too much.
Iter rows is pandas, right?
There is something like that in pandas, yeah, but it's old. It's old Python hiss.
Anyway, right. So if I'm iterating to all of my items, if I try and print the name, I'm gonna have a no attribute. If I look up name, right, I'm gonna get it. But if I do last name, am I gonna get an error? Yeah, I'm gonna get a here error. Right, so I'm gonna get a here error when I try to go through all of my items and try and do it. So what you want to do is you want to make sure the string last name in. You want to make sure it's in the thing before you actually do the computation. Right, and then I just print for the value on it. Right, and so then I have to think about how do I want to handle the entries that don't have a last name, things like that. But yeah, essentially you can do it, what you've been talking about in Python.
And can you now can you add one more array to that dictionary? Just anything new?
Right, so here's how I'm adding a value. Right, I'm calling the value Andre the name. Right, so that works. Well, let's go through a few things. That there was no last name, so it's fine. But now, if I even add a last name,
yeah,
this is going to be fine, right? So I'm updating. Now I'm going to be updating the value at that, and when I print it, I get his last name as well, right? So here I didn't create a new value; I updated a value, and I probably should have done this in multiple steps, but Now we can kind of see that. And let me
Yeah.
comment this out. Right. So there's Andre without a last name. Doesn't get printed. Let me create Andre with a last name. My date has it now, and now it also gets printed. And it's overwriting the same value.
Yeah, and that's why we should have a unique the place in the name. Otherwise, Andre would get if I don't choose a unique value, it's going to get replaced, basically, right?
Yeah, they have to be unique. All keys have to be unique.
Yeah. Okay, and then can you change that to just to make that to a data frame? That's going to be fine, right? No issues.
And the data frame.
Yeah.
Yeah, you can turn it into a data frame easily. Yeah.
I've always thought pandas data frames were arrays of dictionaries or dictionaries of arrays.
They're multi-indexed. They're indexed on columns and rows, so they're just indexed on indexes. But yeah, you should be able to do like you should be able to pass it into PD data frame directly or do from dict, and that'll be fine.
Okay, awesome. Appreciate it, guys. Thank you.
And this has no. Oh, it's capital D.
Oh, big D, big F.
And that.
Big F.
Yeah.
There we go.
Nice.
Oh yeah, no, it's fine.
You should have an end value. Oh yeah, you do. Okay, perfect. Perfect. Yeah. Okay, so yeah.
Yeah, and that actually that point of realizing that you can kind of do this in a dictionary in Python, I think is like a great hurdle to kind of get over in the sense that for a long time I didn't understand how databases work, and then you kind of just realize that they're just like very fast, very performant, but all they do is the same simple operations that you expect in that you can do in Python. So you can write a database in Python. No one would use it because it wouldn't be performant, but at the end of the day, like all these same operations, they exist in Python or whatever database you're using.
I would just add that it might be worth looking at Mongo again. It's likely that the key uniqueness issue is what's causing you to quote lose data in Mongo as well. So take a look at that as well.
Okay, appreciate it. And just one last thing, it's and like for example in the my dict Andre, I can have that as a I can have that at like the name of Andre, I can have that as that unique value, and then the content, whether it's name, last name, whatever, account, URL, all of that, I can just have that preset, and that is like called when I do a single scrape, right?
You're gonna have, when you're doing scraping, you're gonna have to manage your data at some point. It really depends on how the scraper operates, but it would be good to have a layer between the scrape data and you assigning it into dictionary. If you find that the way that it's being scraped, it doesn't produce unique keys in a way that you want, right? So you're gonna have to take a look at it at least somewhat if it's not behaving, because scraping is not an exact science, and it'll produce weird results for you. I think I haven't scraped myself in the past before, but from what I've seen of it, it's only as good as the data on the website. So you just got to be careful with that and apply a cleaning step to it, probably.
Okay.
Yes, and you're going to have a lot of these if statements, particularly whenever you're dealing with unstructured data, and like nested data. You're going to have a ton of these just to make sure your program doesn't crash if it encounters something that it wasn't expecting. So important to know.
Yeah. Okay. Awesome. Thank you, guys.
Of course. And in the future, honestly, I think these types of things are great. And if you ever want to kind of show what you've been working on and get feedback on it, we're more than happy to kind of give our thoughts and criticisms. So feel free to DM me or Tom and be like, hey, I want to like present on what I've been working on and take some time. And I'm sure that'll be super helpful to a lot of other people.
Sure. Yeah. I thought scraping is an easy thing, and you guys are like way ahead the creators and
Yeah,
perfect.
I think scraping and putting in a MongoDB, that would be an interesting presentation. No pressure though.
And actually, I've been doing that in a bunch of like different projects. I'm currently like taking care of. One of them was that Etsy part. One of them is scraping Chase Bank, just to build a database of accounts and routing numbers and whatnot. Um, and I chose the Mongo because from previous experience. So we scraped one of the projects during the bootcamp was just building a scraper for Walmart, Amazon, and Target. So you can just enter a single item and it would just go through all these different websites and get you the prices, pictures, and so on and so forth. So having storing that in kind of like a middle place, it was like useful for us. I think that's the use of the resting API, if I'm not mistaken. So I'm doing that with the current projects. It's just that, for example, in that app, 3 different e-commerce websites, when I want to retrieve the data, sometimes the Walmart data, for example, just disappears, even though I'm 100% sure it's there. Because when I restart the program and I call the objects again from the Mongo, it just shows there with no issues.
Yeah, I mean that sounds like something Andre brought up, which is like validating data, which is a lot harder of a thing, and I'm sure if we looked at it, there is either some bug in the code or some conceptual thing that is kind of isn't happening that you think might be happening, or that is happening slightly differently and producing drastically different results. So my advice there
would it show? Sorry, but would it show like if I start the computer now, log in and see it after I've been running the code for like an hour, and then or working for an hour, and then it doesn't show, and then I switch off the computer, switch it on again, and I look at the data, and it's there. Like this is the issue with me. It's like it hasn't failed twice in a row. It's just that switch the computer off, log in again, and then it's going to be there. That's my concern. Yeah.
I think you might have multiple MongoDB instances on your computer, and that would be a problem. It's a little bit harder of a thing to debug, but
yeah. Okay.
Yeah, my advice would be there to kind of use, instead of using like the Mongo command line tool, is to use Docker, because Docker essentially forces you to assign things to ports, so you'll only have one. And then there's also a thing in volumes where things are actually being stored. And at that point, you're defining it on the file where the information is kind of coming from. It's a little bit more advanced, but I think it's kind of the right way to kind of never come upon those problems. I don't know. Andre, do you have any thoughts?
Okay.
Regarding the Mongo problem, so I was only half listening since you were addressing it, but it's tricky with local databases. It shouldn't I do recommend like using Docker for most things now. Like I don't run like system Postgres or system whatever unless there isn't a Docker variant available. Yeah, but I would generally strongly advise using Docker for this kind of stuff. At least then you can know, because you're gonna have to, at least in the case of databases, you're gonna have to port map them in order to have them accessible from the outside. So you can be relatively sure about the number of instances you're running at any given point in time, and you know what you're talking to essentially. When you're saying localhost 5432, well, that's port mapped to a Docker container, so you can't be talking to anything else.
Awesome.
My other piece of advice would be to write tests. And I know this is something that I didn't do until like a couple of years into coding. But when you're working on like a web scraping project, right, you have a big program doing lots of things. It's very hard to isolate what's the problem is. And so essentially writing test cases is going to help you. Okay, let me see if inserting one record into my database allows me then to read that from that database. And no one really likes writing tests, but it does help you A, isolate the problems when you encounter them, and then B, that again. So I definitely recommend that as like a best practice.
Okay. Okay. I will definitely try that. Thank you so much, guys.
Of course. All right, let's go back to the doc. So we were in the middle of this. Where did we leave off? We talked a lot about the first thing. And we talked about Airflow and DBT. We talked a little bit about Spark Hadoop, but I think at this point I was already starting to hurry things up. And so we can kind of either progress forward into the databases. Honestly, here is what I would like us to do. I'm actually very curious about the commercial solutions. I think we can leave all the things we've talked about for tools as part of the last conversation, and then we'll kind of do another meetup at probably in a couple months to redo everything, and then hopefully add a little bit more structure to that. But I think now we should kind of talk about databases, especially because we just had a great conversation about using MongoDB and some of the problems with that. So I think talk a little bit about SQL versus NoSQL. I am sort of the opinion that these two things are slowly coming together and being more and more similar, in the sense that SQL databases now allow you to do JSON operations in them, and allow you to do basically operations that doesn't need you to have highly structured data already in there. And for the case of NoSQL databases, even like MongoDB, if you go MongoDB documentation, they have query documents. Is probably the right place to look. Yeah. Yeah. So since they will tell you what the equivalent operation in SQL looks like. So MongoDB is slowly starting to look more and more, or behave more and more like a highly performant SQL database, with a lot of the flexibility that NoSQL has. But then again, SQL databases are starting to allow for more and more unstructured data to come in, and then to do operations on unstructured data. So I think this distinction is still very real and still very important to kind of figure out, but I think it's slowly becoming less and less important. Andre, do you have any thoughts on this?
I think it's definitely true that I don't know how together they're becoming. I think that the various competing commercial solutions have realized that they can fight over that they can implement within their existing products. The I guess the competitors, at least a subset of their features. So, for example, with Vertica, which is a SQL database, highly performant SQL database, they have a structure known as flex tables. Now, flex tables are exactly what they sound like. They allow you to be flexible, to insert whatever you want into them without specifying a schema beforehand, which is exactly what the NoSQL camp is all about. It means that you have your random unstructured stuff, shove it into a table, and there it is, right?
I'm sorry, Andrew. What's the name?
Sorry.
What's the name of the tool?
Vertica. It's a commercial database. There is a there's a free, I guess, community license that allows you to operate it, maybe with some limited features. I think it's a full feature setup, but it limits you on data size. You can store up to 1 terabyte in there before you have to pay for a license.
Oh, okay. Vertical.
Yeah, I don't know if they limit features at all. I would think not. But yeah, it's called Vertica. It's a commercial solution. It's what I used extensively in my previous job to essentially get performance SQL queries.
Interesting.
Yeah, but they've essentially implemented this feature called Flex Tables. They have an entirely different product that's Vertica based on S3, which basically scans your S3 data lake, if you will, and automatically basically uses that to as a storage backend, and then you can scale up and down compute as you want. So that's a slightly different concern than what we're talking about. But as you can imagine, you can have random data on S3, and it'll try to handle that without input from you. So that's a NoSQL concept there as well. I think it's more that they have realized that they can sort of shove in these that the SQL people have realized that they can shove in NoSQL into their current architecture and make it work and get some of these customers from Mongo, from the other solutions, with relatively little effort. So they just did that, and they're doing it more and more. And on the flip side, I think that NoSQL is struggling, well, to a certain extent, to get customers who have been SQL users their whole life. So as you saw on that documentation page, they have these translations, if you will, from their JSON query languages to SQL to make it more accessible to people who otherwise don't have experience querying with JSON, with like a JSON query or something like that. Because obviously the SQL is a lot more friendly of a query language than like if you were to take like an Elasticsearch query, for example. It's like you feed it this JSON dict with the key of LE, and then you have this range list, and then it's just hard to follow, right? Where in SQL, it's pretty, you read it top down and you get it, right? Unless it's like something deeply nested, multiple joins, whatever. But at that point, it's like you're an advanced user if you're doing all that stuff. Where you can easily select this from this table with this condition, partitioned by this, ordered by this. That's essentially 90% of SQL queries you will see joined on this. And then it's pretty easy to learn. And I mean, one of the impediments to all of these NoSQL solutions is they essentially define their own query language every single time. Every implementation has its own query language, so they can't necessarily take like an Elasticsearch query and query in Mongo with it. And you can't do that either.
Well, so for MongoDB, I actually have thought about why didn't they just implement SQL on their database, and I don't really have an answer, especially if they're kind of showing documentation what the equivalent SQL statement is based on their documentation. Good reason. To me, I think your point of SQL being highly readable versus these kind of query languages that you essentially define JSON objects that look very, very much like SQL, but like have a bunch of other customizations. It just seems like, wow. But that's one of those things that
You're breaking up one of those
lead devs,
I couldn't quite hear what you said.
I was saying that unless you're talking to one of those lead devs, you can't really understand why they chose that.
Oh, I think if the question is like why they chose that particular way, that query language, I think it's fairly obvious that they didn't want to have to go through defining a computer language, building a compiler for it, or the different compiling steps that are required before, like when you submit a SQL query to Postgres or whatever, it doesn't really matter. They're implementing some version of a SQL standard. and that means that they have pre-compile steps, they have compile steps. They translate that query into probably C, probably something that is understood by the database management service. Now that's a lot of heavy software engineering that goes into that, building compilers and making sure they're bug free and doing all of that, and SQL has refined it over decades since how long has SQL been around, since the 80s or late 80s or something like that. I don't quite know.
Sounds about right.
But what's easier than that is essentially, oh hey, there's this we have this accept query function, and this accept query function expects a JSON structure to go into it, and we can just send that over the wire like that, and we don't have to do anything to it, right? The customer obviously suffers because they're not talking to the service in a high level language, right? So they're forced to send in this sort of data structure that doesn't require any doesn't require any consternation from from the back end receiving it. So yeah, I think that they haven't had the appropriate amount of time to define a human friendly query language.
So I think that makes sense for like a startup to not implement that SQL layer. But at this point, it's like if your documentation.
I think they're starting to implement SQL layers, not startups, but like Mongo.
MongoDB.
I don't know if does Mongo have a SQL translation layer or something like that to allow people to query it with SQL.
I haven't seen anything about it, so I think not.
No, I mean Mongo is Mongo. I think their market share allows them to be a little bit I don't know, maybe complacent, maybe they don't have to do it, and they'll still retain customers and gain even more. I think it's a product decision on their part. Yeah. It's probably, I mean, I haven't personally used Mongo. I assume you query it using JSON, right?
Yeah.
I feel that if any of the old or new SQL commercial products ends up implementing essentially Mongo and then provides a friendly interface to it, I think they're in trouble essentially, because suddenly you have all of the refined aspects of SQL, and then you have this essentially a copy of Mongo capabilities, but with a friendly interface. So it is certainly a problem for them to address at a certain point.
Yeah, I mean, I think Mongo is in a good position regardless. I think.
No, it's strong performance. They're growing.
Amazon has like DynamoDB, which is
Dynamo, yeah.
With Amazon, which does the exact same thing.
Dynamo is more of a Cassandra than it is a Mongo. Yeah. In fact, I think it's basically the same, except it's probably more expensive to run Dynamo than it is to like spin up your own EC2 servers and run Cassandra on them. Obviously, it's a managed service; you would be paying more. But I guess we can go into Cassandra, but it's.
Yeah, do you mind?
It's basically a dictionary on steroids, is what it is. You define your tables. They're highly indexed. Everything is sort of sharded across different servers in what is called your ring. So the machines that comprise a Cassandra data center or cluster.
Elasticsearch?
Hmm?
Is that similar to Elasticsearch?
Well, Elasticsearch is also highly indexed. It's also incredibly fast. Well, it can be highly indexed, right? It doesn't. All of this is optional, but extremely recommended. And Elasticsearch, you can't. So Cassandra is a lot more friendly in that it has CQL, which is basically SQL, but it's like SQL with Cassandra quirks. So it's almost like a like if there was anything between a dialect and the next level. In terms of languages, you have dialects, and then you have, I guess, other languages. But if there was anything between like a dialect and another language, that would be CQL, because it has its own quirks and stuff that you never see in SQL. Like, for example, in CQL, you would have to explicitly enable filtering inside of your query. You'd have to say enable filtering to tell the backend that you want it to slow down to do this query. Because, well, the it doesn't. It is essentially just a hyper fast.
Andre, you're breaking up a little bit. Can you repeat that last thing you said?
It's essentially just a hyper fast lookup database. Basically, we're talking like you can smash it with tens of thousands of queries a second, and it will respond to basically all of them. In order for it to do that, it doesn't have some of the more advanced capabilities that some SQL databases have, like, I don't know, like window functions, or it can't do count, notably. That's like one thing it can't do under any circumstances. It cannot count
the number of records?
Yeah, it cannot count the number of records ever. Because in order to count, it would have to eschew some of its more refined optimizations that allow it to be as fast as it is, and it just won't do that. And it'll basically, if you ask it to do count star on a certain column, it will crash. The database won't crash, but the query will never return, essentially, and it'll eventually time out. So there's definitely quirks associated with using some of these more, I guess, more special solutions, and you have to be really aware of what your needs are and what you're going to be doing before you pick something like this, especially with Cassandra, because while, yes, it's going to be blazing fast, if you need to count and you've already gone to production with this or something like that, you're screwed. And then you're going to have to do some hacky solution outside of Cassandra to actually count, which is what ended up happening to me. It didn't end up happening to me. It's sort of, someone else did it, and then I had to manage it. We had to implement count in Scala outside of Cassandra based on the returned results of a query, which is not fun. And it's definitely not elegant. So it's just something to consider. But yeah, Cassandra, blazing fast. You can run it on however many servers you want. It scales nicely. It can be a bit of a headache maintenance-wise, because I don't know about recent versions, but in the version that I was using, which was, I don't know, recent as of, 3-4 months ago, you have to essentially clean the database on a daily basis. So you have to run your sort of vacuums, your different repairs on the database for because the data gets fragmented as it gets into Cassandra, and if you let it go enough, it'll degrade the performance of the database and cause other issues as well. So there's a lot of things to. Cassandra is highly specialized, and Dynamo is managed by Amazon, which is can be either a good or a bad thing. But yeah, it's a solution for a particular problem. But I would definitely compare Dynamo more closely to Cassandra than I would compare it to Mongo. I have no idea what the performance of Mongo is, by the way. So but there's nothing more frustrating than having slow queries, no matter what database you are confusing. It's just like watching paint dry, like waiting for a Redshift query to come back.
Yeah.
Yeah, sorry, I was going like off on all sorts of tangents there, but
No worries. That's what we're here for. And if anyone else wants to speak, they're free to chime in. Do you want to? So these commercial solutions are actually things that you recommended. I would actually put. I know.
I didn't. No, I wouldn't go so far as to say recommended. Definitely not. I mentioned them as option. Recommend is a strong word. I think that most of these, if not all of these, are crazy expensive. Because what you're essentially buying is a pre-baked ETL solution.
Right.
So I have no idea of the performance of any of these. Illuma is basically a layer on top of AWS that allows you to basically set up like an ETL flow through UI. You know, create a little box, you create another little box, you draw an arrow between them, and suddenly you have a pipeline. At least on their back end, right? So everything is very abstracted away from you, and what ends up happening is that you have very little control over the fine details of your ETL process as soon as you do this, right? So you're essentially giving up control over, I guess, doing highly specialized operations on your data. You're at the mercy of whatever they have implemented on their platform. So with Illuma, I mean, I have a little bit more experience with them than with the other two. It's not MuleSoft, it's MuleSoft, Mule as in like the donkey. That's something that I recently encountered that my current employer or client, I guess, uses to transfer data between SQL servers, Microsoft SQL servers. I have no idea how effective it is. But with Illuma, I mean, it's a layer on top of AWS. You get to define your flows on there. And one of the things that they implemented at a certain point in their product cycle was the ability to, they basically I think this is all of their stuff is driven through a web browser, through a web application that they have built. And what they gave you at a certain point was just like a text editor to write your own Python code. They can just sort of inject into whatever point in the ETL process you want in order to deal with this sort of fine-grained stuff. So it's pretty evident that they and that's I don't know, that seems very hacky to me. Like, how is that code saved? How is it version controlled? What is going on with that code? It lives only inside of Illuma's web browser on your profile. You can't push to it. How do you deploy that code? So it's a very like hacky solution to give their customers fine-grained control over their ETL process. But it in general, I find that it's very useful to retain a certain amount of control over your data flows. And when you purchase a commercial solution, you risk giving up that control, and it's hard if you try to get rid of that solution, because then you have been up until that point entirely reliant on it to get your data flowing from whatever source to whatever target, and now you suddenly have to implement whatever parts of the pipeline you were dependent on them for. So it becomes hard to wean yourself off that. So that's my cautionary tale about commercial solutions. Not that it's easy to build your own custom one. That's why if you go custom, you need to hire data engineers. You need to hire basically a bunch of data engineers to build your pipelines, to select whatever technology is appropriate, to link it all up, write your glue code, whatever else you may need, your connectors, and then you have this whole thing you need to manage. So it becomes like any other software project or product that you're building in house. So yeah, that's my spiel on commercial solutions for ETL. Some of them can be very useful though. There's definitely Informatica is a long-standing player in the market. They have a lot of enterprise customers. I think they have a pretty robust UI for building ETL flows. There's and the name escapes me right now, but there's definitely some tool vendors that give you useful tidbits that you can integrate. And if you want to use commercial solutions, by all means go ahead. And but it's often better if you can find providers that offer like a limited part of your ETL pipeline. Like, let's say there's one that gives you I don't know, automatic schema creation for your CSV data, and that's their product, and you can implement that easily, and then you can have your own code, and it's not like a total solution, right? You can, if you decide you don't like them in the future, you can just sort of more easily remove them from your stack. But if you take like on a whole solution and you make your entire ETL flow dependent on that, then it becomes very hard, especially when your boss asks you for something very custom, and then suddenly there's no way to do it within that commercial solution. So, yeah, that's how I feel about them in general. I've never made a recommendation to use one. So
hire engineers instead.
Yeah, hire good data engineers instead, and you'll have. I don't know if you'll be much happier, and I guess it depends on your.
I don't know
if you're like there's times to use them too. Like commercial solutions, they're not all bad. Like if your entire company, the only thing that they're doing data wise is ingesting like Twitter feed data, that's probably not gonna. That's like a slowly change, like an extremely slowly changing dimension over time. Yeah, sure. Get a commercial solution, link it up, point it at the Twitter API, point it at your database, and let it run, and you're probably fine. And that's all fine. But if you're dealing with messy financial data, if you're dealing with like government data, you have to clean it, you have to like figure out what it is, like nobody knows what it is, then it's probably not the time to use a commercial solution. So probably the messier, the good rule of thumb is the messier your data is, the worse time you're going to have with a commercial solution, because they're essentially made for data that is not that data that is in good shape, not like, I don't know, your yield spreadsheet that's been the data has been mangled a million times, right? But that's it. That's all I have to say about commercial products.
Yeah, I almost want to put Excel as like a commercial solution in like some form.
Yeah, but that's more of a UI data frame with with whatever tool sets and plugins, and God, don't get me started on plugins, that you decide to install on it, and it just has traction. Excel just has traction with everybody, and it's dug in really hard.
Yeah. Yeah.
Andre and Matt, can I ask you a question?
Please.
Go ahead.
Yeah, so I'm very interested in your statement you just mentioned about the messy data, especially from like finance or like governments. So for me, like most of the data that I'm dealing with is from the government. So perhaps that might fall into the messy data. Said that commercial solutions are not really recommended in this sense. And then maybe like it's better to hire a good data engineer. Could you explain a little bit more about why do you think like that?
I find that the commercial solutions don't allow you the amount of control that you often need to clean the data appropriately, especially if you're talking about like time series data or something like that, where you maybe want to look ahead or look behind the current road that you're on in order to figure out what the appropriate value is for a particular field.
Right.
Like, let's say you're fixing, I don't know, balance data, and you need to look at like transactions across time in order to fix that balance. Any sort of windowing capability you might need, it's unlikely that you're going to find in a commercial solution. And in general, I haven't liked the tool sets that I've seen commercially for cleaning data. I find it almost always preferable to if you can, load it into Python or into Spark and then do it that way. Write your own, essentially a pre-processing system for. I'm not going to say the word script because I don't want to encourage the use of scripting in ETL flows. I think that if you're going to go through the process of hiring data engineers, building a custom ETL solution, I think that it should be a production system and not a bunch of scripts that are sort of thrown together and boom, that's your production ETL system. That's not it. But you could definitely build a system, a minimal system in Python in pretty good time that will address whatever need you have for cleaning data, for like moving data between different from different sources to different targets. And I think that the big advantage of that is that you have total control over it. So if you need something in the future, if you need to change, if you're developing new features and you need something from the data that you didn't have before, you don't need to scratch your head as much and consult with the vendor about what is allowed and what you can do within the product. You just sort of tap your engineer on the shoulder and you're like, hey, do this for me. And then they can't say like, oh, the commercial solution doesn't allow it. They basically implement it for you if it's within the realm of possibility and software.
I don't know. I feel like data engineers will. I feel like engineers will, in general, be like, I don't know how possible that is, in the sense that oftentimes things can be a lot more difficult.
Yeah, I mean, it depends on the ask, right? Like I said, the if it's within the realm of possibility in terms of like, yes, I can code that for you, or no, you're asking for something that computers don't do, right? But it's definitely true that if you're both a commercial solution, you're surrendering control over what it is that you can do, because you're operating within a sort of walled garden of whatever that vendor decided that you can do within their product. And
so what I would say,
yeah, go ahead,
is that you never really get rid of the problem that engineers solve, and the profile of tools are appropriate for whatever problem you're given. And so oftentimes people pretend like there are like golden silver bullets. There are like solutions for every single problem, right? Like, oh, this Informatica problem or whatever, this software as a solution or solution as a service, that paradigm. Like at a certain point, you need someone who has a deep understanding of the tools, and you need someone who has a deep understanding of the problem. And like, as soon as you have that, like maybe it's possible one of these commercial solutions is the right tool, but that person is also very capable of probably implementing all of these solutions on their own, and just simply understands, okay, well, I could implement it on my own, but someone else has already implemented somewhat general this, and here's the solution for it. And so I think the reason this is like a highly paid profession isn't just because it's you do a lot. It's because knowing a lot is super helpful. It's so much more helpful than anything else. Like picking the right technology is like 80% of the problem. And if you pick the, you're gonna go a lot better than if you pick the wrong technology and you try like fitting solutions into that. So
we lost it.
That's my whole sorry, I'm just saying the problem that engineers solve, which is picking good tools to fix the given problem, is still the case even if you're using commercial solutions.
Yeah. What I would add to that is that you can. Mine was a little bit breaking up there. I don't know if everybody was just me or everybody. But what I would add there is that often you can recruit for an engineer that knows the engineering side of it, what tools you use in different situations, and then it's at that point imperative that you get them, especially with data engineers, you get them very familiar and very comfortable with the domain, with the business and its, I guess, data domain that's applicable to it. Because at that point, if an engineer is good in terms of technical ability, and then understands the unique challenges posed by whatever data you're dealing with in your business, then they can actually do a fairly good job of deploying the right database solutions, ETL solutions to handle that. Yeah, and it's also important to remember with commercial products, when you're building a product when you're building any product, really, you're trying to well, if you're building it to sell, then you're building it essentially to be as appealing as possible to the widest audience, right? So it's going to be very generic by nature in order for it to be useful to the maximum number of people. And so you're not going to see a lot of features that are tailored for your situation, let's say, because they wouldn't be able to sell that to everybody. They'd be able to sell it to you for a very high price, but they wouldn't be able to sell it in general on the open market. And so that's the problem with commercial solutions. I guess over time their feature set expands as they get more, as they have more room to breathe, and as they establish themselves in the market, you'll see that different commercial solutions implement more and more exotic features. But that only comes with products that are very mature and have a solid base that allows them to develop those features. So you have to be careful with what you're buying. If you're buying a generic tool and you have a generic problem, that's fine. But if you're buying a generic tool for a very specialized problem, then you're going to suffer.
I have a follow-up question regarding, maybe this is a little bit out of topic, but I am a little confused with the pre-processing and the ETL process, so especially the transfer. I thought that for the transfer, like the cleaning process is included there. The pre-process and the ETL, the transfer in the ETL is different.
So I mean, it really depends. This terminology and the way that it's implemented differs from place to place. It really depends on how you decide to structure whatever ETL solution you like. So I mean, ETL classically is extract, transform, load, right? But we've seen it done in the reverse. So you can do extract, load, transform, which means you're getting it within whatever system immediately, and then you're using that system's capabilities to mutate the data in some way to transform it. With different ETL systems, it really, like, what does pre-processing mean? Is it still pre-processing if you do it in the second step? What if you do it in the third step? It doesn't really mean anything. It's just it's a good idea to aggregate your transformations together in one layer, so you can reason effectively about when they are occurring in your pipeline, so that if there's a problem in the future or you need to change something, you don't have to basically run through your entire code base chasing down where this transformation was made. So it's useful to group different to group transforms together into one step, I guess, in your pipeline. And group I don't know, whatever else you need to do that, I don't know, logically should stay together in another step in your pipeline, and then you have something that's and then you have order, essentially. It's really just about order, and then you can name it whatever you want. You can say this is the pre-processing step, this is the you can have a pre-processing step and then a cleaning step if you need to change something before you're able to clean it. Then you can have a post-processing step. It's really just about agreeing on stages, and then and maintaining order in your pipeline and your code base.
Thank you.
Yeah, no problem.
Awesome. Yeah. I don't know if we want to go into data interchange formats, and especially because everyone seems to be having trouble hearing me. I think
you're just breaking up from time to time. I'm not sure if it's distance from the mic or internet or whatever.
Now it's my internet. I have to figure out a new solution. I think now.
You good now? You good now, Matt?
You're good now, Matt. I was gonna say, like, for the
Andre,
future,
I
I can put together something for Arrow, especially since I'm really interested in it, like a little presentation and sort of I don't know, maybe short lecture about its capabilities. If people are interested in that. Yeah, that's all I wanted to say. So we can definitely shelve Arrow for the future if we wanted to discuss it in more depth.
We'll call it at this point, and I just want to say thank you for everyone for coming. You know, it's always a good discussion that we have here, and thank you, Edwin, for the earlier thing, or for the leak footage, and thank you for everyone for asking questions. I think questions are great. They drive out a lot of good discussion points, and they also help us, the people talking, formalize their understanding of what they're talking about. So I want to thank everyone, and we're looking forward to seeing you all next week.
Yeah, thank you, everyone. Keep asking a lot of questions.
You're pressuring us, Mom. Thank you, Mom.
Thank you. Good night, everyone.